Welcome back to the Elite Automation YouTube channel, where we talk about all things automation, whether it be stuff about ROIs, technical things for engineers, or the Manufacturing Come Up podcast that we have. Today, we're going to be talking to you guys about collaborative robots versus traditional robots and which one is the right choice for you. And realistically, we're going to go through the pros, we're going to go through the cons, and hopefully from that, you'll help make a decision. And in the end, we will give our preference on collaborative versus traditional. First and number one pro that we have is you can deploy collaborative robots in places that you could not deploy collaborative robots before. Maybe you had space constraints, or maybe it's in an environment where there's too much human interaction and the humans need to be interact in the things, and all of this may have an impact in your ability to be able to use a traditional robot. So now with the new collaborative robots that we have on the market, when I say new, I mean they've been out 5-10 years now, but they've become way more reliable. There's way more brands that are covering collaborative robots. I mean, there was like only a couple brands in the market at first whenever they first came about. If I'm not mistaken, Universal Robots was one of the very first robots that came out and was a collaborative robot. And then a lot of the other brands started seeing the popularity, started seeing the use cases, and started following suit. So now almost every major industrial robot brand has a version of a collaborative robot on the market. So some of these other use cases may be something crazy like fast food, right? There's places and there's big dog companies like McDonald's putting R&D into automating their kitchens and whatnot. And something like a McDonald's kitchen, they need to be able to have something that they can work around. And even if you did like a robotic cell, if there's an issue, they need to be able to move that robot out of the way and continue running production with the normal human. The collaborative robots have opened up new use cases in all different industries, not just in particular areas within facilities. The next pro is they're easier to deploy, and normally much quicker to deploy. There's less programming involved in doing a collaborative robot, and some of the robots can even be programmed by the touch of a button. Grab the robot, you drag it around to where you want, and you hit a teach button, and then it records that position. So let's say, for instance, if you just need to pick this up, set this down, you can record a position down here, record a position up here, record a position over here, record a position down here, done. You've now programmed a robot. And then you need like some type of loop or input devices. So there is some small amount of programming. If somebody tells you there's no programming whatsoever, they're pretty much lying, because there has to be some type of input. The robot has to know there's a part there, or has to know to do the next step or the next process. So just keep that in mind. You definitely need some type of programming. It's not just touch a point, touch a point, touch a point. Some of the applications for these collaborative robots can actually be as simple as having like a pedestal and some laser scanners attached to that pedestal. You come into your facility, you anchor the robot down to the ground and touch a couple points up and you're ready to go. Especially for a systems integrator like us, we know how to program the robot, so that way there's very minimal things that we have to do when we arrive on site, and also engineer them in a way where we don't have to do a lot of things as well, as far as like electrical wiring or programming definitely, but like that's one of the big things about implementing a robot is the infrastructure. So a lot of times you're having to install fencing and other barriers or perimeters that you don't have to do whenever you're using a collaborative robot. Before I get into the third thing, these things that I'm mentioning are reasons I see people deploying these robots. I'm listing them in an order of the way I see they can use them in applications they could not have a traditional robot. They're easier to deploy, so they can deploy them more quickly than a traditional robot. There's less infrastructure, there's less fencing, any other auxiliary pieces of equipment that may go along with traditional robot. The third one I see is the collaborative workspace. So in the past, you've never really been able to work around a robot, and now you have the ability to work directly with a robot, and even some applications are being used as like a robot arm assist, which is not generally the use case, but there is some small use cases where that does make sense. But it's primarily that you can be standing right next to the robot and the robot's performing its job, you're handing another part off to it, maybe you're loading some tray or something for the robot to then do its next process with the parts. But you can work more hand in hand with that robot than you've ever been able to do. The fifth thing I have is it can be cheaper than a traditional robot solution. Why is that? Well, for the same reasons I mentioned before. Less fencing, less infrastructure, all those things are added costs. Like generally the most expensive thing that is within a collaborative robot that would not be in a traditional robot would be like laser scanners. So there's a lot of times that, having fencing can be just as cost effective as doing a laser scanner. So I'm not going to just say that the collaborative robot is more cost effective than a traditional robot. It's very case by case. Number 6, I already mentioned this, but you can teach the robot much easier with the touch of a button. It's very, very important for individuals, and like if you need to teach new parts or paths or programs, or if you have an issue with picking up a part, you can now teach the points yourself and don't necessarily have to have a controls engineer come in and reteach the robot. The next topic I'm going to bring you guys to is the pros/cons. And the main one that I have is safety. So a lot of people say collaborative robots are safer, but in reality, a collaborative robot is not inherently safer. You'll hear people talk about if you put the knife on the end of a collaborative robot, it's not collaborative anymore, right? So that is one of the big things that you have to think about. We'll get into that a little bit more here in a second. But they are more safe in an instance where you were to actually get hit by the robot. A traditional robot, if it were to ever hit you, it's probably not going to stop. And if it does, maybe it's a really small robot. But a collaborative robot has sensors built in and can detect when it makes a collision with anything, and especially a human. So there is that layer of safety that is definitely safer, but there's the part of them not being safer because if you're working directly side by side with that robot, then you're closer to that robot, you're closer to the danger than you would have normally been with a traditional robot. And something may happen where, you know, maybe the robot's loading parts and you reach in to grab something, the robot reaches down at the same time, and it has a robot tool on it and it crushes your hand. So you do got to be careful with that, and I'm going to get into the cons now. You got to be tighter on your risk assessments, okay? There's a ton of collaborative robots that have went out that do not really meet the proper risk assessment. Somebody did the risk assessment and just basically passed it off. But you got to be careful. If you have like big chunks of metal at the end of your robot tooling, like you really need to be like designing and engineering with plastics so that way they either break if they hit a human or they don't cause any type of cuts or lacerations. That's something you definitely have to keep in mind. And like I said, there's a lot of applications that are going out with robots with big chunks of metal on it, sharp metal, pinch points of the application from where it's doing its pick and place. And you have to be more cognizant of that because before, your robot was generally inside of a cage. And with the way we engineer our systems, you had to hit a safety interlock button. The system itself had to give a signal back from the PLC, the robot, all the pieces of equipment in there saying, hey, I'm safe, it's okay to enter. Then once you open the gate, it safely, safety rated, shuts down all the pieces of equipment. So there's parts of that that is actually a little bit safer, and there's kind of less engineering behind it, right? Because if everything shuts down in a safe state and then you allow somebody into the system, as long as that was engineered appropriately, technically that system is safer. The next big downfall I have with collaborative robots is they're slower. So you're going to get much less output, and they've gotten better over time, but like even if the rating of the robot's like speed was pretty high, what you would see is issues where the robot would start to fault out if you went above like 80%. So if you needed to go over here and then down really fast, that sharp movement from here to here would actually trigger as a collision and the robot would have to fault out. Now they have gotten better at this, and certain robot brands are better at having false collisions. And the other issue is you'll see people that just crank up the safety sensitivity so that way it takes more for the robot to fault out, but then they're not paying attention to how much more force it's going to actually impact a human with. So, you know, by cranking those safeties up, you're cranking up the amount of force required to tell that robot has hit a collision. So just make sure that you're keeping those things in mind. Like I said, the speed is definitely one of the big issues, and a lot of times you might need 2 collaborative robots to do the same as what you would do with 1 traditional robot. And that kind of wraps it up, guys. That's my brief summary of collaborative versus traditional robot. And if you have any other questions, be sure to put them down in the comments below. Reach out to me, ask me if you want any help with collaborative robots or traditional robots. Reach out to us. But overall, if you just want some more education, if you want me to do more videos like this, we can dive deeper into some more pros, cons, and get particular with things. Just put them down in the comments below. Hit that subscribe button for more automation content, and we'll catch you on the next one.